All right. Hello, everybody. Hopefully you can hear us all right, but I am Jason from Makera, or at Mr. Erdreich if you're from the educator maker community, and I'm joined by David Merel, aka Captain Creativity, and we're in a really cool maker space here, which is Captain Creativity space that he works in. But before we get into that, a couple exciting things, right? So first off, thank you so much for joining us for another Makera live stream. Super excited to be chatting with you tonight. The theme is going from 3D printing to CNC and combining all those different things together, which is really what Captain Creativity is super into and does really amazing stuff with. So I'm glad that we'll be able to chat with him about it. But a few super awesome Makera updates and reminders to go through. First off, we are in the middle of the spring sale, right? So there's a lot of really awesome savings and promotions and things like that. If you wanted to consider purchasing any of the stuff that we're going to be talking about tonight, there's a sale that's running into next week. And I'm excited to say that there's another coupon code that we're going to throw on the screen here for our live stream attendees that you can save yourself an extra $100 off with the coupon code SPRING. And that is until April 7th is when that spring sale ends. So that's super exciting announcement number one. Super exciting announcement number two is literally this morning, the most recent release of Makera Cam went live with a couple new features and a couple different improvements and hardware development changes to make it work a little bit smoother. And we'll be demonstrating Makera Cam later tonight. So you can grab the most updated version that just went live today. And you could also check out the change logs on GitHub and all those types of things. And for any iOS users that wants to connect a tablet to your Carvera Air or Carvera, you can now install the Carvera controller app from the iOS App Store as well. So if you want to use a tablet and you have an iPad or an iOS device, that also just went live. So a couple exciting announcements that I wanted to get out there immediately. Really cool stuff. And I see that we have a ton of folks. If you see me looking over here, I'm just checking out the screen. So we have people that are checking out the chat, and Makera is on with us right now to answer your questions. So thank you again for being here, everybody. But now, without further ado, Captain Creativity, say hello. Let us know, who are you and where are we right now?
Hey, guys. So yes, I'm David Merel, and I have a YouTube channel called Captain Creativity, and we do all kinds of projects on there with 3D printing, and hopefully now to expand into the world of CNC and laser engraving, etc. And so I do a lot of unboxings and reviews, but I also do projects. I also create a little bit of curriculum for schools in the field of robotics and stuff like that. And so, you know, naturally, I'm really excited. I already got a chance to start working with
one of
Makera
Makera's Kickstarter backers, right?
Yes.
One of the backers. This is your Kickstarter purchase machine here, right? So an early backer, right? Which is super exciting. We're glad we can come out and visit.
I saw Jason at CES. Like, what was it?
It would have been 2 years ago, right? It would have been CES 2024. Yeah.
And I was like totally blown away by this.
That was the prototype reveal. That was like day one of Carvera Air in public. You were like one of the first people.
I was so excited. I backed it like right there in the
literally
booth.
in the booth. Yeah, that's awesome. And here we are, like a little over a year later. It's sitting here and we're milling stuff.
So I volunteer in a couple of schools as well, and that allows me to kind of be on the ground floor, see what works, what doesn't work with kids and other young makers. And so we're here right now in one of the STEM labs that I put together, and we're gonna get into it now.
It's awesome. It's such a cool space. You know, I'm an educator myself, and whenever you walk into a space that's a little chaotic and projects everywhere, you're like, cool stuff happens here. Like the kids are learning, the kids are creating. I mean, they're doing everything. There's lots of hardware stuff. I got a tour of this building before we started this, and there's a robotics lab down the hall, and just really cool things are happening here. So we're super excited that you'll be bringing CNC milling into this space.
We already have so many ideas how to use that in the school.
That's awesome.
And in our maker lab as well, just in general. It's just so exciting.
That's cool. Doing really cool things with that. And for any other educators that are watching, you know, Makera is, of course, a growing company that's looking to support education. That's personally what I do with the company. So if you haven't already checked it out, we have a small lesson plan series where we're showing educators how to do different puzzles and games. And we have a fidget spinner project and another couple fourth axis projects and PCB making, right? To give educators standard aligned curriculum, design briefs, going through a design process to help bring in subtractive manufacturing into the classroom. So if you are an educator and you want to check out those learning resources, check out our wiki site to learn more on that stuff, because it's definitely helps make these spaces, you know, really engaging and hands-on as we go through, right? So, you know, we have a lot of stuff to talk about tonight, right? Thank you again for being here. We also have a lot of giveaways. So we have a couple different discounts, a couple different bundles, and at the end of the night, even some Carvera Air CNC machines too that we're going to be giving away to our viewers. So stick with us because there's a number of prizes that you might not literally be able to take home because hopefully you're watching this from the comfort of your couch, but it will arrive to your home if you're one of our lucky winners, right? So stick with us because that's coming later. But I think, the first thing that I really want to talk to you about is just, that transitioning, that bridging the gap between the 3D print space and the CNC space. I know that you are an avid 3D printing user. I'm looking off camera. There's 3D printed droids and 3D printed, cosplay masks and projects and parts everywhere around me right now. And it's inspiring. So what do you find in terms of the 3D printing? What do you find to be, the most resourceful aspect of that tech that you bring into your spaces, you bring into your projects? Like, why do you love doing that so much? What does it allow you to do as a maker, a teacher? Where do you see from that space?
Well, it ultimately, and I think this is true with CNC and laser engraving as well, it just allows you to bring your creativity to life. I mean, you're creating, and whether that's through the process of adding material, or in the case here of removing material, you're creating, and it's really so fantastic when you start pairing this with 3D modeling software, and then you get to see what it's going to be first, and then comes the next part, which is let's make this thing come to life.
Right.
And
and whether that's like small scale prototyping projects, or if we do have a number of Makera customers that are doing some type of production, or small scale production and things like that with their other machines. And while we are looking at your Carvera Air tonight, of course, the same type of thing that we're talking about could be applicable to our bigger Carvera machine. So we're just kind of going to reference a little bit of both. You brought up a really good point there, like additive, subtractive.
Right.
We probably have a lot of users that aren't super familiar with the different processes, right? Or even like what the term CNC is, right? So let me pull up a quick little image here to help give you some context on what those CNC machines are, right, as we go through here. So CNC machines describes something that's computer numeric control, right? So you're looking at the Carvera right there. That's a CNC machine, of course, the Carvera Air. So CNC, computer numeric control, means that it's describing a machine that runs off of essentially a set of coordinates, X, Y, Z positions, that just tells the machine where to move and what to do. And there are so many different CNC machines, right? We have milling machines like the Carvera and the Carvera Air. You have bigger milling machines like the ones you just saw on screen there. You have lasers, laser cutters, laser engravers. You have vinyl cutters, plotters, and if you're working in industry, I mean, there's wire EDM and machines and water jet colors, right? And pretty much everything that you own is in some way made with a CNC machine. And even though we don't call 3D printers CNC machines, like we don't call it a CNC 3D printer, they are. Right? Like they run on G code and they run on X and Y positions, just like a milling machine. So typically what you have, the biggest difference between, say, the Carvera Air and a 3D printer is really that tool head, the cutting process, right? The way that it moves and the way that you prepare the design, it's very similar. There's some differences, and we'll definitely cover the differences, but CNC machines fundamentally work in a very similar way.
Absolutely. When I was unboxing this and going through the process, and I had a CNC machine a very, very long time ago. I mean, we had a big one, but it was very hard to learn, and the learning curve was so steep. It was difficult. But I was so happy to get my hands on the Air, and when I got into it, I started noticing that there are so many parallels between the CNC world and the 3D printing world. Like you said, like the three axes that it runs on, and you don't have an extruder here. We have bits, and you can look at something like we're going to talk later about things like shanks and stuff like that, and how you might say like, oh, that's like kind of like a nozzle, right? So there were so many different things, and it was just really, really interesting because we have a slicer, you have a controller, right? So there's all kinds of parallels that we're going to find, and we're going to talk about that today.
For sure, right? So and a big definition is actually what's happening, right? Like the way that you're making your project. You can see I have a bunch of projects in front of us, most of which were made with a milling machine, like the Carvera Air, right? But you really have three types of manufacturing processes. And there's some engineers sitting at home right now saying there's more than three, but there's three main groups, right? So there's three main groups, and 3D printing falls in the additive group. So that's like this clock. You might not be able to see really well, but this is a nice little time clock here, right? And this was 3D printed.
Right.
So it's called additive manufacturing because we start with nothing,
right.
and then you add material to make your part. And in the case of a fused filament fabrication or FFF style 3D printer, that's the kind with a nozzle, like your typical home or school 3D printer that has rolls of filament that squeezes it out through a nozzle. It's added layer by layer. And of course, there's a lot of different types of 3D printers out there. Some work with resin, some work with metal, etc. But all of them start with nothing, add material layer by layer to make your part, right? Subtractive manufacturing is a little different. That's where you put in a solid piece of material. So this started as a solid piece of wood, right? Cut from a tree. And then it removes or subtracts, or for my international folks, it's reductive. I know that some countries refer to it as reductive manufacturing. Removes material, right? So this clock was actually carved with cutting tools, right? So this started as a solid piece of material and the numbers and everything was cut away.
Also layer by layer.
Also by layer, and the fact that we start from the surface of the material and then work our way down in what we call step downs gradually to machine. And if you're working with a soft piece of material like wood, and if you have a really versatile machine like this, you can usually cut pretty quickly, like pretty big step downs, maybe just 1 or 2 or 3 passes. If you're working with a harder piece of material like metal, like some of our metal projects here, harder material means you have to cut a little bit more gently. So you might take more step downs as you go. And then the third manufacturing group is formative. And formative is where you might make a mold over a piece of material, right? So this is a vacuum form mold where I actually took my 3D printed clock as sort of an investment and then made a mold over that. So that's formative manufacturing. And every single thing you own is probably made using one or several of these methods. A lot of people don't realize that 3D printing and additive manufacturing still mostly used for prototyping. We are now entering an age where 3D printers are so versatile and so complex where you can buy some products that are made with 3D print, especially like our makers that probably have Etsy stores. And you can certainly buy 3D printed products there. And there are some mainstream things like some sneakers and Invisalign retainers and things like that that use 3D printing in the manufacturing. But typically a company will 3D print their ideas quickly, test them out, then go mass produce them using subtractive or formative, right? Because, making this clock took roughly, like, I think my 3D printer 6 or 7 hours to make this chunky piece of material. This mold was made in 3 or 4 seconds, right? So, there's a big cost benefit. Milling, if you have like an aluminum laptop that you're watching this broadcast on, that was probably machined with a CNC mill, right? So there are a lot of products that you actually buy and own that are made with milling machines, or a lot of the formative manufacturing, the molds are molded over something that was carved on a CNC. Right. So you might carve an aluminum piece and then use an injection molding or a vacuum forming system to then mass produce that piece using some type of plastic, right? So those are, when we mentioned earlier, CNC, subtractive, additive. Hopefully that helps some of our new users here kind of get a little sense of the difference between what those different processes are.
Yeah, for sure. And, similar to, 3D printing, just as you have different types of filament like ABS and ASA and PLA and TPU, in the world of CNC, we're dealing with like metal, aluminum, different types of wood, plastics, things like that, right?
For sure. So I mentioned that this was, a solid chunk of wood that we carved away, right? And there are so many different CNCs out there. There's CNC mills, CNC routers, which fundamentally are very similar with a slight different cutting system, right? That some CNCs are designed to do a certain thing. Like a lot of big CNC routers are designed to do huge woodworking projects and things like that. Some smaller CNCs are really good at working with, metals and things like this, or maybe making printed circuit boards and things like this. I think one of what Makera as a company and what we try to do for our users that are makers is our brand is the most versatile desktop CNC, right? So every material I just mentioned, from wood, carbon fiber, PCBs, plastics, aluminums, brass, things like that, you can put those materials in the Carvera Air, which, if you want to work with a wide range of materials, even plastics, right? You mentioned ABS. I know that when I was working in school, I always avoided printing ABS in the school.
Right? You don't want to do that.
So a lot of fumes and things like that. So you'd have to have a really, enclosed printer, filtration to do it safely. And that's because as you melt ABS, the off-gassing, the fumes aren't safe. But if you're machining ABS and you close the lid and you have a vacuum, you're not you're not releasing any fumes. There's dust, and you have to contain the dust, of course, to make it safe. But you can machine ABS just fine. So any of those materials can be, machined on the Carvera Air or the Carvera CNCs, right? So it gives you that level of versatility as you're working with your projects. Yeah. And I also love to point out, like, listen, I myself I'm a maker, right? You can find all the stuff I do on my, social channels with everything like that. I know Captain Creativity just loves making things, and Makera is a company of makers, right?
Yeah.
So we use 3D printers all the time. I love doing projects that kind of combine the two, because there's pros and cons, right? Like I mentioned that this clock took like 6 hours or so to 3D print. This only took 15 minutes to machine, So of course this is plastic, this is wood, so there's a different aspect of this part, but this was machined very quickly because it was such a huge chunk of material. And instead of adding all of that material, I just had to remove what I didn't want.
Exactly. And I think that's so important for people to understand that you have to use the right tool for the right job, right? So, when you're dealing with 3D printing, right, because we're adding that plastic layer by layer by layer, you're right. Sometimes it just doesn't make sense to go that method and to just subtract rather than to add. And that's going to happen when you're dealing with much thicker parts.
Yeah.
So yeah, absolutely.
With my drone part here though, right? So these ducts are 3D printed, right? And then the frame is milled carbon fiber, right? So milling these ducts is possible, but because I would have had to start with such a huge chunk of material and remove so much material and leave the smallest amount left, it made a lot of sense to 3D print these ducts pretty quickly. And then most 3D printers would struggle to print carbon fiber, at least carbon fiber in such a rigid way that you could have a flat frame like this. But milling carbon fiber, a flat piece of carbon fiber, was quick and easy. And that let me mill this solid frame out of carbon fiber, 3D print these ducts, and then really combining those two different manufacturing processes to give me this final project, missing the motors and the wiring. It's not finished yet, but the frame is finished. And again, the pros and cons of both technologies there.
Now, Jason, when you have to buy materials, like in 3D printing world, we have Easun, Sunlu, we have all these different manufacturers. You could buy them from so many different places.
For sure.
Amazon, whatever. Where do people go typically in this universe to buy materials like blocks of aluminum, things like that? Where would you advise them to go?
That's an awesome question, and that's one we get a lot. Makera is a manufacturer of CNCs. We don't manufacture our own materials, but we do sell materials. So a lot of the materials that we support, and if you buy the machine, you get your little material sample pack, right? That comes with it. You have your Kickstarter kit, right? So yeah, you get your little material sample pack that comes with materials included with every machine that you get, right? So you get all those things to help, and that includes some aluminum, some I think there's an ABS block in there, some PCB stuff, some epoxy, right? So we do sell materials, but we don't make them, and we also certainly aren't proprietary. So you can source material from pretty much anywhere.
Right.
So it depends on what you're trying to make, right? And it also depends on where you are in the world, So I know that here in the United States, we're actually surrounded by a lot of different lumber yards.
Right.
We're surrounded by even some big, lumber hardware stores that have some, not just framing lumber like 2x4s, but some nice polished walnut and nicer pieces of material that you can just go to your local hardware store and pick some of that up.
Is Home Depot okay?
Yeah,
Is that
Home Depot, Lowe's, right? All those places, depending on where you are in the world. They now are like the DIYer world is bringing some of that stock in. So you can get a really nice piece of wood from those. You don't have to go to a traditional lumber yard. And then there's also metal supermarkets. So there's metal supermarkets all over the place. I know we're coming from you from the East Coast in New York, right? There's metal supermarkets everywhere where they have rough cut stock, where they have leftover stock, and that's usually you pay by the pound, and that's usually the cheapest place to get metal. Then there's also some big vendors. Again, in the United States, we have places like Grainger or McMaster-Carr that would sell that stock to you as well. And then even Amazon, not so much for metal, but if you're going to make PCBs, if you want to get flat carbon fiber, a place like Amazon, and I'm not, please don't think that I'm just promoting these stores. There's a lot of options out there, right? Again, depends on where you are in the world. Do sell, I buy plywood from like a craft store because I find that they sell the best like thin 1/8-inch ply at like my local craft store, where I also get paint and markers and stuff like that. So you can, unlike 3D printing, where maybe there's a lot of different manufacturers, but also you typically buy all the filament from the same place. You go to a place like Amazon or Micro Center or something like that, or you buy it right from the manufacturer. With CNCs, depending on the material you're trying to get, there's a million places you can go. There's places that only really do metals, only really do woods, only really do crafts. And again, you can kind of throw any material in that machine that you want to work with, which is super cool.
Pretty awesome.
It is. It is. It is. I think, you know, before we get into our next topic, I mentioned that there's going to be some giveaways. Let's do our first one. So our first giveaway, get your keyboards ready. Our first giveaway is going to be for our spring sale. Our spring sale. I mentioned to you that we actually, I'm sorry, it's going to be another sale coupon. I mentioned to you that we have a sale right now. So what we're going to be giving away is we're going to be giving away even more discount codes. So we're going to give away five $500 coupon codes. So let me
$500?
$500 off an order here. So let me share my screen and I'll give you a little bit more context on that here, right? So let me see. So giveaway tool. So get your keyboards ready. Here you go. You can see this here, right? So we're going to be giving away a $500 coupon discount code to 5 viewers right now. And a couple important things to note. In order to get these prizes, any of the prizes that we're giving away tonight, we want you to follow the Makera channel. And if you're one of our winners, all you have to do is you have to reach out to our team, which is info@Makera. And you can follow the Makera channel, which is @Makera. And then you could reach out to us with your YouTube account and show us that you followed us. And then we'll send you your prize. And in the case of this $500 discount code, we'll be able to email you that code. And you can apply that to any purchase that's more than $2,000 that you're buying. And so $500 off of that order, and that's going to be valid until the end of April 30th.
And so to be clear, you're going to go to Makera or Makera. You're not coming to me. I don't have any $500 coupons.
But Captain Creativity viewers, you're eligible too. So get your keyboards ready. Here we go. Save yourself $500. The keyword is #500. So let's go. So let's enter right now, #500. We're going to select 5 viewers. I see we have 66 entries. Get your keyboards ready. It's counting up here a little bit. #500. This will save you $500 off an order until the end of April 30th.
And that could be for the whole unit. Could be for accessories.
Yeah, anything over $2,000, you could save yourself $500, right?
Wow.
And again, we also have the spring sale going on the next week, so that we already have some discounts and savings that
Could they bundle those two up?
Yeah, so the spring sale is just discounts. We have discounts until next week, and then if you want to save yourself an additional $500 on our current discounts, right?
Amazing.
But again, this is until April 30th. So if you want to save yourself $500, you can use this coupon code until April 30th on any order over $2,000. I see we have 100 entries. We're going to give away 5 of these right now. So 5 people are about to get a $500 discount. So I'm going to give us another couple seconds here, and then we're going to draw, and we're going to see who our first winners of the night will be. And again, we have a number of prizes. So if you don't win this time, stick with us. We have more prizes on the way. So here we go. All right. 111 entries here. I think we're going to draw. Ready? 112. All right, here we go. Winner number 1 for $500. I always forget drumsticks every time we do this. I'm always like, I need it.
I love how the names like slow down.
Oh, all right.
There you go.
Max Del, I'm sorry if I butchered this, Vicio, or the Noise Tank, right? You Noise Tank 01. You are our first winner. Awesome job. So again, to claim this prize, you have to follow Makera YouTube channel. That's @Makera. And you have to reach out to our team, info@Makera, and we will send you this. But Max, you're not the only winner. Here we go. We're going to pick another winner here. I got to change my screen resolution so I can push the button to draw again. And here we go.
All right.
Winner number 2, $500 off your order until the end of April 30th for an order of $2,000 or more. Moritz. I apologize. I butchered the names, just like my students. It's awful. All right. So winner number 2. That's awesome. Again, same thing. Here we go. We're going to draw again. That's winner 2 of 5. We're giving away $500 discounts here, folks. So winner 2 of 5. Here we go. Let's see, who do we have for winner number 3? eCapstone. Congratulations. You just won $500 off your order. That's fantastic. Here we go. Winner number 4. I realize we have people from all over the world. I'm going to apologize in advance if I get somebody that I don't speak. Okay, here we go. So Original Gumshoe, congratulations. You are winner number 4 of the evening. So we have 4 winners. We have 1 more for this $500 discount and savings. Ready, set, go. Here we go. Winner number 5 of the evening. I like the Stormtroopers. There we go.
I know, me too.
That's like right in your alley. Kevin Jurgens, congratulations. You are winner number 5. So to our first 5 winners, again, you have to follow the Makera channel and then reach out to info@Makera with your YouTube information here, like your YouTube account, and show us that you followed. and we will send you that $500 coupon code that you can use until the end of April 30th, on an order that's more than $2,000. So congratulations to our first 5 winners. But that is not the only thing we're giving away tonight. We have some bits and we have Carvera Air coming up soon, right? So stick with us. We have more winners, but congratulations to the first 5. It's fun giving stuff away, right?
It is.
Super fun. Yeah. Awesome. All right. So I think the next thing we can talk about is maybe getting into actually doing a project, right? I think we're almost 30 minutes in here, so I think maybe we can start to do a project.
Well, that's a great idea. You know, the kids here, they're actually looking to do name tags for the lockers.
That's awesome.
And then I know the administration wants to also work on putting some new tags on the doors.
That's awesome.
Things like that. So that's a
name tags, which could also be like trophy plaques and things like this, where you can carve that. You can carve different room numbers and anything like that. Those are awesome projects. And what do your students typically use to design in?
Tinkercad.
Tinkercad. That's right. I know you and I, we both enjoy it, right? I'm a big Tinkercad fan as well. So that's cool. And what we're describing right now is CAD, C-A-D, computer aided design, right? And we mentioned that there's some similarities between CNC milling and 3D printing, right? So a lot of our 3D printer users are probably familiar with Tinkercad or another 3D CAD program. There's a lot of great ones out there. I know I also use Onshape, Fusion, SolidWorks, right? So all those CAD programs will help you create a 3D design. And the difference between CAD and another key term, CAM, is that we use CAD, like Tinkercad, to design the model. And then we use CAM to prepare it for manufacturing.
Like a slicer.
Like a slicer, right? So a slicer is a very specific type of CAM that's really only used for 3D printing. And it takes your layer and slices it. There's other CAM programs, like for example, Makera CAM, which is our own CAM program. And there's other great ones that we support. You don't have to use Makera CAM with our machines. A lot of our users like Fusion, SolidWorks, VCarve, Kirimoto, right? Mastercam. There's a ton of great ones out there. Some of them also will work for 3D printing. So for example, Fusion will prepare things for 3D printing as well.
Yes.
But they also help you create what's called toolpaths, which is for milling, routers, lathes, right? As you go through and as you work with your different machines. So those are 2 really important terms you need to be familiar with, is that you have CAD, which is where you design your part. And then you have CAM, which is you prepare it. So CAD is computer aided design. CAM is computer aided manufacturing. And listen, we also know that a lot of users maybe don't design the parts. They buy the models, you download the models off of like file sharing sites like Thingiverse and things like that. So the cool thing about working with the CNC is you can import a 3-dimensional part. Right. You can also import a 2-dimensional design too.
Well, is that always, or is that now available with something that you guys do?
No, so CNCs traditionally were 2-dimensional designs. Like for example, I mentioned a huge CNC router I used to work with a lot. I'd bring in a 2D path, and the 3D part of my design came from the material. So this would just be a 2D image of this carving. And then what gave it the 3-dimension was the fact that I was cutting into like 1.5-inch stock.
Gotcha.
Right. And then, but there are CNC machines that can work with 3D. The Carvera and the Carvera Air and in Makera CAM specifically will let you import pretty much any file, whether it's a 2D like DXF or SVG that you can draw on like a graphic design program, or a 3D model like an STL or a step file.
Because that's what we work with is STL files. Pretty much.
Yep. So you can work with those depending on what you're trying to do. And then also you can bring in Gerber files for PCBs if you want to make PCBs. Right. You can work with a wide range of files because they're versatile machines. They can do a wide range of things, right? You're not just making 3D stuff. You're making, like this is, you mentioned tags, but like the safety glass required sign, right? So that's something that you can create using a 2D image, even a JPEG. You can just bring in and machine that image file.
That's one of the things we didn't actually mention. I don't think we really covered the PCB component. I thought that was pretty insane.
Yeah, it's cool,
that we can create our own PCB. So if you're like working in robotics or Arduino and Raspberry Pi, etc., to be able to create your own PCBs is really fantastic, and it really kind of streamlines the entire creative process. And this thing actually does it, which is so cool.
Yeah, I'm going to pull up a little video here to help showcase exactly what we're talking about right now as we're going with. So before I guess we get into the tag, right? So before we get into the tag project,
By the way, what is happening here? I
yeah,
noticed
so
that.
right.
Yeah.
So let's talk about what making PCBs and the fact that there's a lot of different types of projects you can do,
Okay,
right?
yeah.
So PCB, which stands for printed circuit board,
Mhm.
inside pretty much every electronic device you own, including the laptop that you're using right now to watch us, and the video camera and the microphones that we're using, is a PCB, a printed circuit board. And that's what connects all of your components, right? So that's what connects LEDs, that's what connects buttons and switches and all this different stuff here. That's what actually connects to your different the different things that you're working with, right? Printed circuit boards. So with that printed circuit board, to machine that, there's a couple of different ways that you can make a printed circuit board. You can make the printed circuit board, and let me just make sure that this is catching up here. Hang on one second. I want to make sure that I'm showing the right thing on screen, which is cool because I don't know if I am. Hang on one sec. All right, that's good. I think there's just a bit of a time delay there. That's cool. All right, awesome. So you can use PCBs and you can machine them on the Carvera using a piece of copper, right? So you start with a piece of copper like this, and this can be purchased from our PCB fabrication pack, or you can source that copper from a lot of different places as you go. And this copper is then milled like so, where we can actually machine and cut away the different traces of our PCB to manufacture our designs as you go here, as you're making this different part, as you're working with it. And you asked what's going on right there. What
Yeah,
you
that blue liquid, because I saw there was an optional accessory to get something to draw. So yeah.
So the way the PCBs work is they have some part of the PCB that's conductive, that allows current to flow.
Right.
And then they have some part that's insulated, that doesn't, right? And what we do is we mill through the copper to be able to have an insulated path. So that way when you solder your LEDs and things like that, the current flows where you want. But when you look at this piece of copper, this whole surface is conductive.
Right.
So if you're going to put that PCB in a slightly hazardous environment where there might be moisture, water, whatever it is, you want to seal that PCB. So what you're looking at there is a copper coating or a solder mask. So in the machine, after you actually mill the copper here, so after you mill the copper away, you can actually use the PCB fabrication pack to coat it with a UV solder mask that will seal the PCB, make it, not waterproof because obviously the contacts need to be sealed, but make the surface coated to give you a much more durable PCB, and then actually machine the solderable pads using our solder mask removal tool to give you a much more durable, much more real-world PCB prototype that would reflect, again, what you have in all your different products. You also mentioned the laser, and one cool thing that you can do is you can actually use the laser to etch the solder mask. So this is the Carvera Air. So after you actually apply the solder mask, you can actually use the laser module that's in front of you there to etch the letters and the solder mask, and then wipe away what you don't need. And all this is showed in our PCB fabrication pack. And then this allows you to make, real world PCB project. We actually just released like a little Raspberry Pi powered Game Boy console that was a really cool solder mask PCB that lets you create your own electronic projects and things like that.
Yeah, so it's really cool. So you're not just getting a CNC, but you also have the option to have a little bit of laser engraving, and you have PCB, and then you have this fourth axis tool as well, right?
Right, yeah, for sure. So with the Carvera, our bigger machine, the laser module is built in. With the Carvera Air, it's this optional accessory here that actually loads just like a normal tool, right? So let me pull up my little laser clips to kind of show you guys what we're talking about right now. This guy will just literally load right into the Carvera Air as if you're loading another bit. And then that turns your Carvera Air into essentially a diode laser engraver that will let you not only engrave PCBs like we just showed, but do a wide range of laser projects as you're working with different types of materials and things like that you're going with, which is super cool. Super cool, super cool. So working with the laser module and things like that is just another way that you can make a more versatile CNC project and things with the Carvera Air. Even like when you want to work with fabric and things, which is what you're seeing there, like a nice flexible fabric. That's typically not a project that a CNC can do or a milling machine can do, because it'll just rip fabric to shreds. But if you throw the laser module in, it lets you create some really cool versatile parts.
What type of laser module do we like? Which one is this? Is this
a 5-watt diode laser? So it's a class 4 5-watt diode laser.
So what materials could you reasonably work on with this?
Yeah.
And like how thick? You know?
Yeah, so it can engrave a lot of materials. So if we're talking engraving, you can engrave on woods, you can engrave on some types of plastics designed for laser cutting.
Right.
So they're safe to laser cut.
Right.
Because like not, for example, not PVC, because that's
Right.
not safe to engrave
Right.
on any laser. But there are certain plastics that you can laser engrave.
And they also have to be dark, right? Because otherwise it reflects off or something like that.
Yes and no. Yes and no. So if you are working with white material that would reflect, or for example, clear stock that would reflect with the diode.
Right.
But then in those cases, you probably end up using the milling head, right, as well. So looking at my this LED sign here, right? So this wasn't done with the laser. That was actually done with the milling head. You can actually engrave. So, but you can engrave a lot of materials, fabrics, felts, foams, woods, engraving. If you actually want to cut through with a diode laser, realistically, 1/8 of an inch is going to be, or for example, about 3 to 4 millimeters is going to be the thickest material. And that's mainly going to be some type of soft wood, like a birch or pine plywood, or maybe cardboard, for example, or fabric. But then what you can do with your CNC milling machine, because you have the laser and the mill built in, you can, for example, laser engrave. So this is another clock that has laser engraved numbers, but then the clock itself was cut with the mill. So most lasers, like full desktop lasers, can arguably engrave maybe faster than what the Carvera can do, because they're designed to be a laser, but they'll struggle to cut through anything that's more than 1/2 inch thick. But your milling machine can easily go through a 2-inch thick material, no problem, right? 2-3-inch thick material, depending on your bits that you choose. So you can combine the processes, laser engrave something and machine something all at the same time.
You know, there, like you said, there's so many ways to do the project, right? You could do it this way, though. Do you ever like look at a project that you're going to do and you're asking yourself, okay, do I etch it? Do I laser it? And then how do you make that decision at the end of the day? You know,
when I started doing all this making, and when I started to teach this type of stuff, I really had like a machine.
Right.
And I was trained on traditional hand working machines, right? So I would always think like, all right, if I can make this stuff by hand. And then I got my first CNC, right? And I was like, everything was CNC. And then I got my first 3D printer. I was like, oh, wait a minute. I could 3D print this, or I could mill this. And then I got a laser. And I was like, now I can do anything, right? So yes, there's never one way to do anything. And in that, I make a lot of mistakes. Sure we do as makers, right? So sometimes I get it wrong. And that's where being able to work with cheaper materials to prototype and test out our ideas is just a good workflow. We always recommend, we have a lot of users that work with metals, because our machines do that quite well with aluminum and brass and softer metals, right? But we always urge our users to first cut your part out of something super soft and cheap, like epoxy tooling board, right? So before you just throw in like a chunky piece of aluminum and you break your bits because you're new, which is fine, you're going to break bits when you're just getting started. Start with something soft, prototype with something soft, maybe 3D print your part to see if you like it, and then go machine it out of solid aluminum, because that takes time, and it's also obviously a lot more expensive too. So I usually start with a prototyping approach, cut something kind of quickly, maybe not super refined, and then work my way up to do a more refined project.
You know, when I just so you know, like when I got this unit and I took it out, it was just getting started was just so easy. Like I'm so used to doing in the 3D printing world, obviously things have been getting easier and easier, and we have less setup. But this really had like zero setup. I mean, there's like, I think the only thing I did was I screwed on this like holder on the side for the controller, which is optional. You don't have to do it.
You don't have to use a tablet.
And I plugged in a wire, and then that was it. Like I was like ready to go. And I actually ran through that same material that you were just, what was that material?
It's epoxy. It's epoxy tooling board.
Epoxy tooling board. I did it and it came out perfectly. I'm definitely going to tell you that the example, I loved this examples guide. This thing was, it's awesome. I highly recommend that before you do anything in starting to create your own projects, just like go through these, because these are fantastic, and it was very helpful to me.
Yeah, and that example guidebook and this LED sign project, that pirate ship carving you just mentioned, are all, even this Nefertiti, 4th axis engraving, right? Those are all example projects, right? That's not to teach you the CAD side of things. That's not to get you up to speed with the design side. It's to get you up to speed with using your machine, loading your tools, clamping down your material, getting you comfortable with using your machine with some pre-programmed projects that are actually preloaded on there. And I also want to share, I'm going to share on the screen here real quick for users on where you can always learn more about these things, not just in the guidebook, but also on our wiki site, right? So our wiki site has everything we just mentioned. So for example, if I scroll down here, I can go to the Carvera Air manual, which is on here in a digital version, and we can actually see, you know, those example projects. Like for example, this is the 3-axis, and we have a YouTube video to walk you through everything that you have in the guidebook as well. And then if you do want to also get into learning the design side, so not just the preparing side, and you want to actually learn how to design the project, we have our knowledge sharing page, which has more start to finish, longer tutorials, longer projects, and also a bunch of sample files that you can download here, of course, for free from our wiki.
Is that R2D2 version in the samples by any chance? Because I saw somewhere that this had like an
R2D2 the R2D2 version of that is in there, so that's preloaded in our examples.
Okay, cool.
And the other thing I was going to say is Makera has, I don't even know the count anymore, 4,000, 5,000 active users. So our user community is growing rapidly between Carvera users, Carvera Air users, and they're awesome. So definitely also check out our public Discord group, our public Facebook group, because people are constantly sharing files, tips, tricks, strategies, sharing all these different designs. You know, such an awesome community that we're really fortunate to have using these machines. So you mentioned, like, where do I start? I usually start in the Discord, seeing what other people are doing and asking a question, or I'll reach out to the Makera team and be like, how do I do this? Like, well, what is the best approach? And I'll learn from the people around me. Even though I've been doing this for over a decade now, you can never stop learning with that.
And hopefully one day somebody will take all these amazing project files and put it into an online.
Stay tuned. Stay tuned.
Yeah,
there's more things. There's more things. We have a lot of exciting things in the pipeline, one of which is making a better community and a better way for allowing our users to share things, collaborate things.
That will be awesome.
And we're constantly trying to improve. So stay tuned for more on that. I think we got a little tangent, but it was good. Hopefully you're enjoying this. I think let's do two things. Let's do another giveaway.
Okay.
And then let's make something, right? So we keep mentioning bits. One of the biggest things you need with your CNC to have success are bits, right? Cutting bits and things like that. So we're going to give away right now, we're going to give away 2 essential milling bit bundles to 2 of our users.
Oh, wow. Okay.
So get your keyboards ready here, folks. Here we go. Let me pull up our giveaway tool again. Please hold. I'm going to pull it up on the screen here. All right, let me share my screen so you guys can see what I'm doing. Okay. All right, get your keyboards ready, everybody. This next keyword, again, we're going to give away 2 bit bundles to 2 lucky viewers, and the keyword is #bits. #bits. Here we go. #bits. Let's give everyone a little bit of time here. #bits. There we go. Now we got some folks coming on in. #bits is the keyword. That's counting. There we go. Rapid keyboard typing, #bits, because again, 2 of you are going to win our essential milling bit bundle. I don't even know how many bits it comes with. A lot of bits.
There are.
Tons of things. Engraving bits, cutting bits, thread milling bits, like everything you need to do all the types of projects that we've talked about thus far. We're going to give 2 of those bundles away. And on this, you know, I mentioned that we sell materials, but we also sell bits, of course, but the bits are non-proprietary. So yes, we sell bits, but they're not, we don't make them. We source them, and we sell bits that are high quality for our users. But you can also, just like I mentioned, there's places to source materials from. There's also places to source bits from. And while the Carvera and Carvera ship with a 3.175 millimeter or 1/8 inch bit size collet, the machines can actually handle all the way up to 6.35 millimeter or 1/4 inch. So you can actually change the spindle collet and go to bigger bits. If that's something that you want to work with, depending on the types of projects too.
And when we talk about things like the collets, if we were trying to explain it like in the 3D printing world, right? The larger you go, you can remove more or subtract more material. And that's similar like to nozzles, where you have a nozzle, you can go 0.4 nozzle, 0.6 nozzle. And so the bigger the nozzle, you can add more material.
We can definitely make a connection between that, right? So the collet is the thing that actually physically holds the bit shank, right?
Yeah.
And that has a diameter, like I just said, 3 mil or whatever it is, right? Just like your nozzle, right? So where the nozzle of a 3D printer is pushing that filament out. And like you just mentioned, small nozzle pushes a small amount of filament, big nozzle pushes a lot. A big collet will let you hold a big bit, a 6 mil or 1/4 inch bit. And if you have a big bit, you can just remove more material more quickly because you have a bigger cutting tool. Let's give away some bits. 150 entries. Everybody ready? We're going to give 2 bits away. Winner number 1. Again, I need the drumsticks every time. I forgot. There we go. That's a good one. That's a good drum roll. Who's going to win the first bit kits? Oscar 959, congratulations. You are our first bit winner. And same as before, you have to follow the Makera channel and then reach out to info@makera.com with your YouTube information so we can mail you this bit kit. But Oscar, you are not the only bit winner. We're going to do one more. One more bit bundle. Here we go. Yes, right. A good drum roll here. Who's it going to be? 152 options. Skylar Rock Special. Congratulations, you also just won a bit kit, your essential milling bit bundle. So again, follow @Makera for the Makera YouTube channel. Reach out to info@makera.com with your YouTube information, and then we'll be able to coordinate with you and mail that bit kit to wherever you are in the world. So thank you and congratulations to our next winners. And that's not it. We're also giving away a Carvera Air. So stick with us. We're going to do that at the end. Now, let's get back into this making a project, right?
Cool.
I'm going to be honest. I knew you were going to say, let's make a tag. I knew. I knew that we were going to get into that. We did talk before I came out here. And I also knew that, like me, you're a huge Tinkercad fan.
Yes.
So let's see what I have here. I did a little Tinkercad work, and I designed this Captain Creativity tag, right? So I think this is something that we can machine pretty quickly here, and we can go through the whole process. So this was designed in Tinkercad. And in Tinkercad, I could download this as a couple different options, right? So if I select my model, I can export this as an STL or an SVG, right? And there's some pros and cons to both of these. An STL file is considered to be a mesh file.
Right.
And I describe it to folks that if you take something like chicken wire or some type of wire and you throw a blanket over the wire, it's a mesh. And what meshes do is they allow you to have a lot of detail in a pretty compact file. And they're great for making engravings and 3-dimensional carvings, right? So for example, that pirate ship example we looked at, the Nefertiti carving on 4th axis, right? Those types of engravings are really good to use STL files. Or like, that Groot, that wood Groot, right? So those are really good for STL files. But what STL files don't let you do is they don't let you select individual intricacies. You kind of have to select the whole face. So looking at this tag where I might want to do a couple different operations, I might want to drill something. I might want to engrave something. STLs wouldn't be the best option. The better option would actually be either from Tinkercad, an SVG that I'm going to download, or a step file, STEP, which is a 3-dimensional file that, unlike an STL, lets you select individual faces. So it depends on, we mentioned that Makera Cam lets you import a lot of different types of files, which it does, but each file sort of has its own pro and con. So depending on the type of project you want to create, you might want to choose the type of file, the right type of CAD software to help you design for that type of project.
Okay.
If you think about it that way.
So here we exported a
SVG, an SVG, right, from Tinkercad. So let me stop the share. All right. And then let me switch to Makera Cam, which is our cam software here. So let me pull up. Sorry, guys, I got a lot of windows that I'm juggling. So here we go. Makera Cam. Let me share this screen.
And for people who are in Tinkercad, if they want to have a reflective working area, what would be the dimensions you want to input in there when you're working in Tinkercad for something that you might take out of there and then bring it into Makera?
So that comes down to your stock, right? So that comes down to the actual material, right? So we're going to be making this with this bicolor sign material that we kind of looked at earlier because it's great for making tags and signs and things like that. It's also pretty quick that we can machine it. But let's say I want to make something out of a piece of aluminum. I'd want to know what the size of that aluminum is. Is it 3 mil? Is it 5 mil? What are the size of that? And then I would want to make sure that I design around that size. So before, when you start your project, you should really kind of know what material you have to work with. Because again, unlike 3D printing where you start with nothing and you add material, in milling, you have to start with that block of material. So if I want to make something that's 5 inches long or whatever it is, I need to know that I have a piece of material that's long enough to actually do that.
But in terms of the build size in the air,
Yep.
what's the max working area?
It's about the same size as a typical piece of paper. So it's about 9 inches by like a 10 and 11, 11 inches or so, like that, right? And then your height is about 5 inches or so. But you have to fit both the material and the bit.
Got it.
So if I want to cut through 5-inch thick material, I can't also fit a 5-inch bit.
No.
Right? I can fit like an engraving bit and engrave the surface of a big, thick piece of material. But if I want to, so like your maximum cutting depth, and the Carvera is a little bit bigger than the Air, but they're pretty close in size. You know, the maximum thickness might be around 2.5 inches or so, like that.
That's
and all
pretty
the specs. And we have all those specs on our
that's
website.
pretty
That you
sick.
can,
Okay.
especially because I don't know them all in millimeters, and I apologize to our international viewers. So we have those on our website as well. But here we go. So Makera Cam. So if you install one of the newer versions of Makera Cam, you're going to see this window pop up that asks you if you want to start a 4-axis or 3-axis project, and you can attach the 4th-axis module to either the Carvera or the Carvera Air, right? So I'm going to click 3-axis because we're just doing a 3-axis project. And the first thing you want to do in Makera Cam is set that material, right? So up here in our stock, I'm going to say that we're working with a piece of plastic. It says plastic material. I'm going to set the size of the plastic and the thickness of the plastic, which I think, I'm going to read the little sticker that comes on it here because it tells me, is 1.3 mil. And that will then set up our document to be the size of my material. So then it's very obvious of like, hey, wait a minute, I don't have enough space to do what I'm trying to do, right? So that's step one, is set the stock in Makera Cam to match the actual piece of material that you're working with. And you probably saw real quick that there's a lot of stock built in here, but you can also add your own stock. So if you actually head over to the material library, you can go in and you can add your own materials. So if you want to work with something that's not predefined, you can add materials. And we have YouTube videos to do all of that, right? So,
and how does this work with the probe in terms of, because we're setting the height, but I know there is a built-in probe here.
Yep.
And so, you know, if you know the height, do you need the probe? I mean, how does that work?
That's a great question. So the probe really is going to check to make sure that the stock is set correctly in the machine, right? So in the CAM software, I'm going to say 1.3 millimeters, right? The probe is then double checking to actually figure out, okay, where is 1.3 millimeters? Where does it start from, right?
We know what
so
that
it actually calibrates everything.
So that's bed leveling.
It's very similar to a bed, like a BL Touch
3D printing.
Yeah.
Okay.
So let me import. I'm going to grab this this SVG tag, right? So here's our tag, and I'm just going to real quick in Makera Cam. You do get a number of like super simple transform tools. So I can move something, and let's say I didn't design it to be the right size. I can change the size of it here. I can scale things pretty easily, and you also get some basic CAD functions. So let's say that I didn't actually create these holes in Tinkercad. I can actually draw some basic holes, and I can do some basic CAD work here in Makera Cam, which is cool. So we have our design, we have our size. The first thing that we need to do is we have to create now, or not the first thing. The first thing to actually manufacture this is to create the tool paths.
Right.
And that's what tells the CNC, do this. And looking at our design, you usually start with the smallest type of cut and then work to the biggest type of cut. It's just usually a general practice because the biggest type of cut will do the most stress. So we want to save that for last, right? Because if we put the stress on first, we might shift something, and we don't want to do that, right? So I'm going to select these 2 holes because they're rather small. So I'm going to click and select these 2 holes, and then we're going to create a drilling toolpath. Now, there's a lot of settings. There are a lot of settings in CAM, but we at Makera worked really hard to give you a good starting point. The default settings that as long as you set the correct stock, so I said I'm going to work with plastic, these numbers are going to be configured for the material that you choose. They're not necessarily the quickest or the most detailed, so we definitely recommend as our users get a little bit more comfortable, just like you might change your custom print settings and fine-tune things a little bit, feel free to start to experiment with that. But they're a great starting point to make sure that you can find success immediately, right?
By the way, Jason, I mean, we hear it upstairs. Somebody must have gone upstairs in the school and
I think there's a dance party upstairs. So hopefully these noise cancellation microphones are doing their job.
I would love to ask the audience if they actually.
No one's commenting saying, "Are you guys in a stampede?" So I think we're doing okay sound wise. Good job, microphones. Right? It's a little loud here, so we apologize. We are in an active school community right now. All right. So now the one setting we have to do is we have to say how deep do we want to cut. So I said that my material is 1.3 mil thick.
Okay.
I want to drill past it a little bit. I want to make sure I drill all the way through. So I'm going to set my cutting depth to be 1.5 mil.
Right.
So that's going to drill just a little bit past.
And that's going to be okay because we have that spoil board.
Yeah, we have a piece of wasteboard. And guys, we're going to switch to the machine, so you'll actually see how to do this here in a minute. Then I'm going to select my tools. So we preload all the tools that we carry in our store. And you'll notice that because we're doing a drilling operation, it automatically threw me into the drill bits. Makera Cam knew that I was trying to drill something. So it said, hey, here's your drill bits. And I know that my holes are 2 millimeters. So I'm going to click on that 2 millimeter drill. And you'll also notice that it knew I'm working with plastic. So it automatically said, all right, you're doing a drill operation. Here's your drills. I said I want to make a 2 millimeter hole. It then said, well, I see you've selected plastic. So let me set your speeds and your cutting settings for plastic. Kind of like if you say PLA in your slicer, the slicer will then configure everything for PLA.
Right.
This Makera Cam just configured everything for plastic because that's what I set my material to first.
But is there like a little bit of give here if you like chose like not the 2 millimeter hole, like, but you choose something a little bit different? I mean, how off the rails will it get?
Well, it depends. So in my design, I drew 2 millimeter holes. If I selected a 1.5 millimeter drill bit, it would use the design, but the hole size would actually be 1.5 mil, which in this case we probably get away with. But if you were trying to actually make an engineering part that you need to be accurate, you got to make sure you're choosing that right tool for the tolerance and the accuracy that you're trying to do. But that was it. So then I'm going to hit calculate, and that's going to set up our holes, which is cool. The next thing is I'm going to select the text here, and this is going to be a pocket, which is going to be an engraving. Right? So same thing, we're going to set our cutting depth, and I don't want to engrave too far. I'm going to engrave just 0.2 millimeters, 0.2 mil. So we're just going to engrave the surface of this. Then, again, I'm going to select a tool, and this time we're going to head over to our engraving bit. So it didn't show me a tool right away because there's a lot of different tools that you could use for engraving, but you'll see that this is actually broken down by the type of process. So if I head over to engraving bits for non-metal, I can select one of my non-metal engraving bits, and then you'll again see that it highlights the plastic settings for me. And then if I wanted to, I can fine tune these things. One thing that you might want to look at is you might want to set your tool number. If you're working with the Carvera, it has an automatic tool changer. So whatever number you set here will be the tool slot it's loaded in. With the Carvera Air, it just flashes at you and it tells you what tool to load. So I'm going to just leave that as the default and hit calculate. And that go ahead and it carved our names. And then the last thing I'm going to do is select this outline. And this is going to be a contour, which is sort of a profile path. And just like with the drill bit, I'm going to go a little bit past our material, so 1.5 mil. I'm going to select a different tool that's meant for creating these outlines, like a little 2 millimeter end mill. And again, you'll see that my plastic was preset for me. All my settings are preset. And if I want to cut on the outside of the path or the inside of the path, you can choose that. Of course, we want to cut on the outside of this because we don't want to cut into our part. But you get some basic settings. One thing that you typically do when you're cutting the part out of the material is you typically add tabs. And what tabs will do is they're kind of like biscuits that hold on to your part. Because think about this for a minute. If I have a piece of material and then I cut my part out of the material with a spinning bit that's going 10,000 RPM, what happens to the material? It flies out, right? Now it's fully enclosed. So you close the lid. So there's not necessarily a safety concern when you have your lid closed, but it's going to damage your part, might damage your bits, right? So typically what you'll do is you'll put tabs on, and then after it's cut, you might use, we give you a little hand saw in your toolkit, or you might use a file or something like that, or a chisel if you're working
just
with wood,
to knock it out.
just to knock the tabs out. In this case scenario, though, we're working with such thin material, we're not going to use tabs. We're going to use double-sided tape. So it's just going to be sticky tape. It's going to hold it down. It's going to hold it in place. So we won't actually have tabs on this. But this,
and by the tabs, you're talking about the metal, these
no. So those brackets will hold the stock in place. The tabs will actually be physically on the stock.
Oh, okay.
So it's going to save here. Let me set it for you real quick. I'm going to go back into this. So let's add tabs here just so you can see. If I actually click on the outline and recalculate this, notice if I look at my tool path, you'll see that there's a little spot right here that it didn't cut. It missed this spot. You can see this triangular shape. So that will remain as a little tab to hold that material in place that you would actually cut with, like, in this case, scissors and an X-Acto knife. This is pretty thin material. Right. So there we go. That is essentially a crash course in CAM, right? Where you bring in your model, you select your material, and you create your tool paths. And listen, of course, we're going through this really quickly right now.
Yeah.
But we have so many YouTube videos and tutorial videos, and again, an awesome active community where you can dive deeper. In fact, for Makera Cam, I think we have 30 different videos that shows each of these features in much greater detail, step by step.
But I have to tell you, you know, I'm looking at this, and this kind of feels, well, first of all, it really does feel like a very easy to use slicing software. I love the big icons all along the top part, the how you're kind of navigating that bed just reminds me so much of like Tinkercad a little bit. And so it's very clean, the interface. And I really like that.
There's a lot of CAM programs out there. And again, you can use any CAM program that you want with our CNCs. But when we designed Makera Cam, the reason that we did design Makera Cam, and it's only barely a year old at this point, was because we had so many Carvera users saying, well, there isn't a CAM software that can do metal and PCBs and lasers and fourth axis. So we had users, and I saw somebody ask this in the chat, can you use Lightburn? Yeah, sure. So we had users, and I was one of the early Carvera users, that I was using Fusion for this, and VCarve for this, and Lightburn for this, and Copper Cam for this. And I was using 4 different CAM programs for my one CNC, and Makera kind of decided, that's fine, if that's what you want to do, but it could be simpler. And that's what Makera was designed to be a more intuitive, a more simple, more easy to learn. Learning CAM is hard. There's definitely a learning curve. You have to take your time, watch your videos, ask for help. But we wanted it to be the simplest CAM approach.
But the hope is that with AI and things like that, things are going to hopefully just get better and better, right?
Indeed, indeed. Yeah, this is as I mentioned, we just did a release today. There's more in the future. There's more coming. So we're definitely looking to always make it better.
And when you said before about the different, you know, cutting depths and the speeds and everything, I came across this when I was unpacking the unit on page 50 of this instruction manual. If I'm not mistaken, right, this kind of gives you a nice guide of what, you know, what tool you're going to use for PCB, what tool you're going to use for wood. And it'll tell you what the milling depth is, what the feed speed is, all that good stuff.
Absolutely. That's what we want to do, is we want to give you as many. And listen, there's always nuances. There's always specific and crazy, like one-off projects that you need custom settings and custom tool paths. And we push our users to do it. And there's awesome stuff shared on Discord to do it. But there's also like a general rule of thumb of, if I'm doing engravings, I'm doing this. If I'm working with wood, I'm doing this. If I'm working with metals, I'm doing this. So we try to give you all those defaults, all that starting places to start from, those starting parameters to get you up to speed pretty quickly.
And I think another cool thing, another parallel to 3D printing is when we're talking about how to make sure that this thing mills correctly, right, and comes out correctly, those little pieces there that you were putting on, you know, that there's a parallel to that with supports in 3D printing to ensure that your print comes out okay.
For sure.
There's the same concept here, you know?
For sure, for sure. So let's mill this. Right? So here's what I'm gonna do. I'm gonna change our camera. If I can do this here. Ready? We're gonna get real fancy. We're gonna switch to the close cam, I think. Let's see.
Is it on?
It is. There we go. So there's there's the close cam of the machine. And let me also take this away, right? And if you want to actually head over the camera real quick, if you can just rotate that camera for me a little bit.
Sure.
Yeah. So make sure that everyone can see.
Am I in this direction?
Yep. So come over this way just a bit. There we go. Cool. Right. So everyone can kind of see what I have going on here. Right. So I have my material, and this is double-sided sticky tape on the back of the material here. And I'm just peeling off the double-sided sticky tape. And I'm going to insert this on the bed around these clamps.
So you're still going to use those clamps?
I'm going to use the clamps to hold the material in place. So I'm just pushing down the sticky right now. But I'm going to use the clamps, and I'm going to use the screws here to secure the stock. So this is going to hold the stock, and all these clamps, all the screws, right? This all comes in the toolkit that comes with the machine.
Now, are we going to have to define at some point, like, you know, the offset of those? Well, you know, those clamps are kind of going over the piece, so we don't want the tool to hit it, right?
Yeah. So you asked a second ago. You asked what the probe does, and let me just zoom in here a little bit. Right, so let me see if I can refocus. Sorry, guys, give me a second. There we go. That should be a little better, so we can see.
Well, right, it's a little high. I only see the horse. I don't see the.
I'm just looking at the probe where the spindle is. Right.
Oh, okay,
So,
fine.
sorry, folks. Hang on one sec. Technical difficulties. You know, we did prepare and we did set all this up ahead of time, and then I think I bumped my camera and moved it. So you asked about the probe, right? So I'm now going to insert the probe here off the side. So this is the wired probe. And the probe is not only going to be used to calibrate the height of the material, the probe is also going to use a little laser pointer to show us where the material is and to make sure that we're not going to cut into those clamps. So let me reshare my screen, guys. What I'm now going to switch to is I'm going to switch to the Carvera controller app, right? So the Carvera controller app is a free app that you can run on iOS. Sorry, just making sure that you can see it. Yep. You can run on iOS or Android devices. And in the controller app or a laptop, like right now I'm on my laptop, in the controller app, I can select that file that we just prepared in CAM. And then what I'm going to do is I'm going to, if I want, change the position of where it is on the bed. So we're looking at the actual bed of the machine right now. And I can also choose to enable scan margin, which is what that laser pointer is, and also use auto leveling, which will figure out if my material is warped at all to make sure that we get a perfectly smooth cut. So I'm going to push run. And let me just switch back to having the full screen of the machine here. And what I'm going to do is I'm going to start the machining sequence and move my camera over here nice close up so you guys can see what the Carvera Air is going to do as I move the bed. And we're leaving the lid open right now, just so you guys get a better shot of this. So this is actually now tracing the perimeter of our design to make sure that we are not going to collide with that clamp. So I can actually see where that laser pointer is, and it's showing me exactly where that's going to be, so I can be confident that, you know, we're not going to hit that clamp. And now the probe is going to lower and actually touch the surface to find that height of the material there to say, all right, we mentioned it's 1.3 mil. It's finding where that material starts from.
Right.
So we know where essentially our zero height is. And now it's checking that zero height across the stock because the stock's a little flexible. Maybe my tape wasn't perfectly flat. The Carvera Air is going to figure out if there's any deviations in that. It's going to automatically machine around it and compensate for that really nicely.
Oh, so in many ways. Also, again, like in 3D printing, where we auto the Z.
Yeah.
And it does, you know, the same idea. Like we don't do the paper test anymore. We literally just have a thing probe it, and then it measures the appropriate Z height.
Exactly. Now, let me show you this tool change, right? So it just now came up here and it's beeping at me and telling me to load tool number 1, right? So I'm going to pull down this quick release lever and remove the probe and then grab tool number 1, which is going to be that drill bit, and insert the drill bit into this. And just so you guys can see better, we're not going to run a vacuum. So I'm going to take off the dust chute. So we're not going to run a vacuum on this. We'll leave the dust chute off just so you guys can see the operations a little bit better. So the drill bit is loaded, and I'm going to push go.
By the way, I love the fact that the dust chute is magnetic and it just comes off like so easily.
And guys, I apologize for shaky cam. Hang on one sec. I'm changing the position of the cam to give you the best view of this entire machining process here, guys. Sorry about the shaky cam for a minute. But there we go. So now we're going to be able to see our Carvera Air drill our holes. So this is going to drill the holes in the design. It's plastic. And that was it. That was our 2 holes.
Yeah.
That quick.
And just remember, if you're doing this in a classroom, you're going to close this lid, okay?
Yep.
And if you are going to open it up and you're just standing in front of it, you should probably put on your protective goggles, because if this stuff flies in, you don't want to get hurt.
Absolutely. And there is a sensor to detect whether the lid is open or not, which we've disabled for the sake of demonstration purposes. So that way, when the lid is open, it'll stop cutting, which in a school setting is absolutely what you'd want to do. So I just loaded our V-bit, our engraving bit. I'm now going to press continue on the machine. And this is now going to check the length of that bit, right? So you don't have to, in a lot of CNC machines, you have to measure that bit each time to actually figure out, like if I put in a bit that's longer than the other bit, you have to recalibrate that. All that's done completely automatically with the Carvera and
Right.
the Carvera Air. So it's measuring the length of the tool during every single tool change, even though it is a manual tool change. And this is going to start and just engrave our design, our tag.
Oh, there it goes.
Yep.
That's so cool.
Let me zoom in here a little bit, give you a bit of a close-up of the live machining of our tag.
Now, just guys, just FYI, another reason that I really wanted to get into milling is, you know, some of you, if you're into making props or parts for robots, you know, there's like that whole R2 Builders or Astromech forum, and it's a great place to get parts, like, you know, like where you could go ahead and buy milled parts, and they're very, very, very expensive, and they only do these runs every once in a while where you can get this part or that part. One of the great things about having your own CNC is that you can literally make your own parts for your robots. And
Absolutely.
you know, since we're in the dawn of robots now, I really see so many people saying like, look, I need to fabricate something for my robot, and you're going to probably want to use something like aluminum or something like that.
For sure.
And now you have your own CNC, and you know, see, my head always goes straight to robots or like lightsabers.
You know what? You and I were talking about making a lightsaber on the 4th axis. I think we'll save that for the next live stream.
Oh, for sure.
And here's the really cool thing, right? People think that machining aluminum or copper or whatever is super hard, like difficult to do, because it's, you know, oh, I need way more caution and things like that.
Right.
The only difference in the design process was when we were in CAM and I clicked plastic. If I had clicked copper or aluminum, and if I selected bits for copper or aluminum,
right,
that was it. That's the only change. So the same design, right, can be used. It just comes down to, if you're going to machine a harder material like copper or aluminum, it would be cutting a lot slower than what we have right now, and also it would be a little bit louder, because machining away metal is a little bit louder than this plastic. So hopefully everyone can still hear us okay with the lid open here, because we are standing right next to our machine and we're machining plastic. But it would be a little bit louder, of course, if we were working with a heavier metal, and we would have to cut a little bit slower when you're removing metal. You know, you have to work a little bit more cautiously with metal as you're machining away your metal designs and things like that. But the actual design and aspect of it, you know, the process would be very much the same. So all we would have done is we just would have selected a different material and make sure that we were choosing the right bits in our design here as we went along.
And there is on the machine a port for dust collection, and also for air, which will help in laser engraving, as well as in where else does that air assist help in? Yeah,
so the dust collection, which is really, if I was doing this in my shop at home, I would definitely be running the dust collection. I would have the dust collection on. I'd have the shoe down, because you can see that there's just a little bit of a mess that's coming on the bed. It's not too much, right? But I'd want to contain that. But of course, the vacuum would be a little bit louder, so it wouldn't be ideal for the stream setting. So I'd have the dust shoe on, and you know, that would work better in a general workflow. The air assist could be used for also moving the dust away. So not so much if you're working with plastic or wood, but if you're working with metal and you're removing metal chips, those metal chips are going to be really hot. And if you have really hot metal chips, you don't want those to be around your cutting tool. You want to make sure that you clear the hot chips away from your cutting tool, so you don't accidentally overheat your cutting tool. So you can use the air assist to actually blow those chips away as a chip cooling system. And give us 1 second here, guys. I just did the last tool change. So you'll see in a second, we're going to do that contour cut, and we're going to cut out that tag as I just switched to our final end mill here that it's going to come around. So to answer your question, yes, you can use the air assist for laser to reduce scorching. You can also use it to blow chips away. And if you're doing something like the 4th axis, you can't use the dust shoe, right? Because it'll collide with the 4th axis. So the air assist is a great way to do chip evacuation with that. So here we go. This is going to take just a minute. You're going to see this single flute end mill work around.
And is this where we're also going to see where we're not going to cut it completely off?
Because the double-sided tape is going to hold in place.
Oh, no, the double-sided tape. Here we will. Okay.
So it is. So this is now cutting out that part all the way around. And the only reason it's not going to eject and fly around
because of the double-sided
is the double-sided tape, right? So the double-sided tape is going to hold it in place.
What materials can you do that with, and how thick of the material? Can you do that double-sided on everything?
I have users that use hot glue and double-sided tape on just about everything. I have users that will hot glue aluminum to their bed and then just peel the hot glue off.
Hey, look at that.
But listen, it basically comes down to, it's not so much the thickness, it's how much load you're putting on the material, right?
Understood.
So if you're pushing really hard on the material and you're putting a lot of load on the material, the tape and the hot glue just physically can't handle that load, right? So it's less about the material and it's more about the amount of load and stress. So if you're cutting in really shallow step downs, you should have a really good approach. So here we go.
By the way, big kudos to whoever put this LED light.
Oh, it's good, right?
This is like a super high-powered LED light.
Yeah, it's good.
It is really good.
It makes live streams look really good too. I had to
Oh
grab
my
a
God.
tool though to get underneath this because the double-sided tape is doing a really good job at holding this in place here. So hang on one second here, guys. Let me pull this up.
I could get a flathead for you if you like.
Let me see. I should be able to make it work. I might have put a little bit too much on.
We are in a STEM lab.
Yeah,
so
let's get a flathead.
let me
Let's
go
do
get
better
a
job,
flathead.
to get this double-sided tape off here. But it looks like we have a pretty fantastic tag, which is just what we wanted to do. It's just adhered so beautifully to your spoil board.
Try this.
Thank you, David.
There
All
you
right,
go.
here we go. So let's grab this piece of material and let me flip it up for the camera so you guys can see.
Oh, that's so nice.
Where's my camera there? There you go. So there's our Captain Creativity tag, right? And then this double-sided tape, you can use any double-sided tape, but this is actually the tape that we provide in our kits. I find that it actually peels away really nicely.
Can we show them the one that you made for me?
Yeah, while we have the close-up cam. So
Yeah,
I
while we have
mentioned
the
that you
close-up.
could do it in aluminum, right? So let me just peel away, right? So the double-sided tape peels away pretty easily. But yeah, go ahead, bring in that aluminum, right? So that's pretty cool.
That is so cool.
So that was just a picture, right? So that just started, that was the same thing of what we did earlier, except that instead of bringing in an SVG file from Tinkercad, I literally just brought in your logo as a JPEG and prepared the toolpaths around a scan, all in Makera CAM, which was pretty cool.
That is so neat.
Yeah, it was awesome. It was awesome. So that was cool. So guys, that was a start to finish. And also, if you could just throw this while I have the close-up cam.
Oh, yeah.
Right, so there's the same tag, but done in brass, right? So same project. The only difference would have been preparing the toolpaths for brass, right? So pretty cool stuff there. So let me bring us back up to our main cam so you can see us again. Hello. Hi, guys. So listen, that was start to finish from a CAD program, creating the toolpaths. I know we did it quickly, but that was start to finish machining something in like 12 minutes there, which was pretty cool, right? And I think with that, because we are just at the end of our time, we have one more super important thing to do.
Giving away one of these?
Giving away a Carvera Air. So get your keyboards ready.
Oh
it is
my
the
God.
final giveaway. Hang on one sec. I got to do all the button pressing. I know it takes me a second. Hang on. Let me press all the buttons. Here we go. Let me share my screen so you guys can see what we have going on here. Giveaway, sharing the screen. Get your keyboards ready, folks. We're going to give away a Carvera Air, and the keyword is #Air. Ready, steady, keyboards, let's go. #Air. We're going to give away a Carvera Air with the sample pack materials and the toolkit that we mentioned earlier, right? So who's going to take home, not literally, but who's going to receive an Air that we're going to mail to you? As a reminder, to be able to win this, you have to like the @Makera channel, right? So @Makera on YouTube, you have to follow us and become a subscriber for that, right? So follow our YouTube channel. And of course, if you are the winner, you can reach out to us, info@makera.com, to go ahead and receive your prize. So who's going to get one of these machines? I know you enjoy it. I love it. It's definitely, I am fortunate enough to have both a Carvera and a Carvera Air at home, and I use both machines quite a bit. But the Air is such a fun, easy machine to use.
Oh, wait,
Put your phone away. No cheating here.
I want another one.
I know. You need several, right? So we got 155 entries. We're giving one of these away. Who's it going to be? 157. I'm going to give us 5 seconds, folks. #Air. I see some of us are entering it like 1,000 times. You can only enter it once. The software is smart enough for that. So only one entry. 160. Here we go. 161. 1 second. Get your comments in. And let's draw.
All right, here we go.
Who is going to be our lucky winner, our final winner of the evening? Who's getting a Carvera Air Desktop CNC? Erdreich. Congratulations. You just won a Carvera Air Desktop CNC. Make sure you subscribe to the Makera YouTube channel and then reach out to info@makera.com. And again, that goes for all of our winners tonight, right? So for all of our winners, we had a bunch of winners from the $500 discount code which was the first winner that we said. We had 5 winners that got that $500 discount code that you can use until the end of April on any order over $2,000. We then had winners. We had 2 winners for the bits. And now our 1 lucky winner for the Carvera. Congratulations to all of you. And for anyone who didn't win, first off, thank you again for joining us. And remember, the spring sale is going on until April 7th, so until next week. And you can save yourself an extra $100 on top of the discounts that are already happening using the coupon code SPRING, right? So everyone gets some savings. And again, thank you so much for joining. So listen, first off, David, thank you. Thank you for inviting me out here. It was great that I live close enough that I can make the drive and come here and spend some time in your space and get hands-on with your machine. And I really appreciate you inviting me and Makera and all of our viewers and all of your viewers here to join us tonight. So thank you so much for your time.
And we're definitely going to be doing that project with the lightsaber.
Oh, we're going to be doing the lightsaber.
We're doing a lightsaber.
I knew that you were a Star Wars guy. I myself am too, and I tried to get one together, but I think that we already covered so much tonight that maybe we'll save the 4th axis machining and the lightsabers for the next one. It's coming up soon, right? So, folks, again, thank you so much for joining us. We really appreciate you being on here. Stay tuned for more content from Makera. Check out some more educator stuff from myself, too, at Mr. Erdreich. And check out, of course, Inventors Assemble and at Captain Creativity for what awesome stuff David does in his 3D printing and now CNC community. Thank you, everybody. We'll see you next time. Cheers to wherever you are. And again, until next time, have a good one, guys. Happy making.